fairness. When the mathematical expectation or expected gain of a game is greater than 0, it's advantageous to the person playing. When the mathematical expectation or expected gain of the game is less than 0, it's disadvantageous to the person playing. In the world of casinos, we'd say that in a game that is disadvantageous to the person playing, favors the house. And the reality is, all games of chance at a casino favor the house. When a game's mathematical expectation is equal to 0, the game is considered fair. That is, given a person plays an infinite number of times, they can expect to lose or gain nothing. A game consists of drawing a marble at random from a set composed of 5 red marbles and 4 blue marbles. It costs a person $10 to place a bet. If a blue marble is drawn, the person wins $12.50 plus their initial bet back. If a red marble is drawn, the $10 bet is lost. Is this game fair? We start by looking at what's the probability of winning. So the person wins if they draw a blue marble. There are 4 blue marbles out of a total of 9, so the probability of winning is 4 out of 9. Therefore, the probability of losing is 5 out of 9. Now, the net gain, if they win, is equal to their $12.50 winning plus their initial bet, and then you have to subtract the initial bet. The reason we have to do both of these is because it tells us that when they win, they get the $12.50 plus their initial bet back. However, they also had to pay out $10 at the start in order to play the game. So the two $10 end up canceling out, and the net gain is the $12.50. Now we can calculate the expectation or the expected gain, which is equal to the probability of winning times the net gain plus the probability of losing times the net loss, which in this case is the $10 that it costs to play. So we've got 4/9 times $12.50 plus 5/9 times minus 10. We multiply this out, we get 50 divided by 9, and we subtract 5 times 10, which is also 50 over 9, which nets out to 0. So therefore this game is fair. Here's another example. For $2, a person can participate in a draw for a $50 gift card. The probability of winning the draw is 1 out of 100. Is this draw fair? So the bet, which is also the loss, is $2. The win is equal to $50, but we need to look at the net win, or the net gain, which is 50 minus the $2, or $48. The probability of winning, we're told, is 1 out of 100. Therefore, the probability of losing is 99 times out of 100. Now we can calculate the expected gain, which is the probability of winning times the net win plus the probability of losing times the loss. The probability of winning is 1 out of 100 times the net win, which is 48, plus the probability of losing, 99 times out of 100, times the loss, which would be -2. When we do that math, we end up with an answer of -$1.50. So based on that, we can say that the game is not fair. Add this to your memory aid. Try the practice questions in the workbook and check your answers against the answer key.